Let us see the phase diagram of a pure substance. But before going for this, we should actually know what a phase is. Phase is nothing but part of a system that is homogeneous. Homogeneous, that means having the same physical and chemical properties throughout. Same throughout. Physically and chemically. This is, of course, a phase. And this is separated from the other phases by a definite boundary. Okay. Part of a system that is homogeneous, which is separated from the other phases by a definite boundary. For example, in case of a pure substance, the different phases what we observe are solid, liquid, and of course gaseous. Forms of a pure substance generally constitute the different phases. Okay. Solid form, liquid form, gaseous form, or of course solid, a phase, liquid is a phase, gaseous form is also a different phase. Now these are separated from one another by a definite boundary. Okay. Solid and liquid, liquid and gas, solid and gas, all these phases are separated from one another by a definite boundary. Even liquids also, which are immiscible, are separated by a definite boundary. For example, if you consider an immiscible liquid, oil and water, even that will also have a boundary between them. They are immiscible, oil and water. Okay. This is all about what a phase is. So let us take the phase diagram of a pure substance. Then we'll go for the phase diagrams of water and carbon dioxide. Let me first draw the phase diagram of a pure substance. In fact, these are all known things. Different phases, or different forms of a pure substance. Okay. Let me first draw. Pressure in atmospheres is taken on y-axis. Temperature in degrees centigrade is taken on x-axis. Now let me label this. Say this is solid. This one is liquid. Then this is gas. Now this T is the triple point. You may be knowing, must have come across. Triple point. Okay. Let us also see something about the transformation. Solid to liquid. Melting. And now if you consider this, liquid to solid, freezing, right? In a similar way, liquid to gas is of course vaporization. And then gas to liquid is condensation. Okay. Then this solid to gas is of course sublimation. Then gas to solid, generally call it deposition. Okay. So this is the phase diagram of a pure substance. You know, it actually tells us what are the phases present at a given temperature and pressure. Now you can see the different phases that are present at a given temperature and pressure in case of a pure substance. Let us also see point C. You know, this point C is called a critical point. We are very much aware of this. The critical point is a point where we generally go with critical temperature and critical pressure. I mean, the temperature and pressure corresponding to this point are TC and PC. What is TC? TC is critical temperature. PC is of course critical pressure. You know, critical temperature is the temperature above which a gas cannot be liquefied. I mean, there won't be any existence of liquid. A gas cannot be liquefied even by applying a very high pressure. You know, by applying very high pressures, the thing what we finally get is a highly compressed gas or a supercritical fluid. This is a supercritical fluid or a highly compressed gas. It no longer be a liquid. Okay. Of course, the pressure and volume corresponding to this particular temperature are the critical pressure and the critical volume. In fact, the minimum pressure that must be applied to liquefy a gas at its critical temperature can be called critical pressure, right? Now, even we have something that relates the liquefaction and the TC. You know, TC is critical temperature. Greater the TC, greater is the ease of liquefaction or liquefaction. Then, greater the intermolecular attractions, greater is the TC. Of course, greater is the ease of liquefaction. Okay. In general, if you observe, polar molecules have high values of TC. so are easily liquefiable. Whereas the non-polar molecules have very low values of Tc, not that liquefiable easily. Very low values, that means you will have chance only up to that particular temperature, because beyond that you cannot liquefy the gas. Okay. So this is all about the phase diagram of a pure substance. We'll now go for the phase diagrams of water and carbon dioxide. Some specific examples.